In the middle of the ocean between the islands of Java and Sumatra, there was a small but powerful volcano known as Krakatoa. It sat in the Sunda Strait, part of a chain of islands in what is now Indonesia. At first glance, it didn't seem especially dangerous. It was just one of many volcanic islands in the region, mostly covered in trees, with steep rocky slopes and quiet coastlines. But Krakatoa had a violent past. Old records and local legends told of earlier eruptions long before the 19th century. Some even said entire civilizations may have been affected by Krakatoa's earlier explosions. Scientists later found layers of volcanic rock in the area that hinted at a massive eruption many centuries earlier, possibly one of the largest the world had ever seen. By the 1800s, the volcano had been silent for a long time. People lived on nearby islands and along the coasts of Java and Sumatra without much worry. The waters around the island were busy with trade ships and fishing boats. The land was rich and full of life. Then, in May of the year 1883, the first clear sign appeared that something was changing. Without warning, Krakatoa began to rumble. A column of ash shot into the sky, surprising nearby ships and startling villagers who could see the black cloud from miles away. At the time, it didn't seem too serious. Many believed the volcano was just letting off a bit of pressure. But scientists of the time, including Dutch colonial officials, took notice. Some began to record the strange activity, keeping notes on the ash, the small earthquakes, and the changing color of the sea near the island. Still, no one could have predicted what was coming. What started as a quiet island in the sea was about to become the center of one of the most powerful natural disasters in recorded history. By the middle of August, in the year 1883, Krakatoa was no longer quiet. The warning signs had become impossible to ignore. A thick black cloud hung over the island, and loud booming sounds echoed across the sea. Ships passing through the nearby Sunda Strait reported seeing ash fall onto their decks. Some described the strange sight of lightning flashing from inside the ash cloud, something now known as volcanic lightning. On Sunday, August 26th, the first massive explosion happened just after noon. It was so loud that it was heard more than 1,000 miles away in Perth, Australia, and even farther in places like the island of Rodriguez, over 2,800 miles away. People thought it was the sound of gunfire or cannon blasts, but this was only the beginning. That evening, and into the early morning hours, the volcano erupted again and again, each time with more force. The island was breaking apart from within. Tremors shook the ground and the sky turned completely dark with ash. The sun disappeared behind thick clouds of dust and rock, and it seemed like night had fallen in the middle of the day. Then came the largest explosion of all. On the morning of Monday, August 27th, just before 9 o'clock. The force of this final blast was unlike anything anyone had ever seen. A huge part of Krakatoa, including the entire northern portion of the island, was blown apart. The explosion sent ash and rock more than 20 miles into the sky. The pressure wave from the blast traveled around the entire world 4 times. Nearby islands were devastated. Coastal towns on Java and Sumatra were shaken to their foundations. But the worst part was not the explosion itself. It was what followed, a massive, deadly tsunami. After the final eruption tore Krakatoa apart on the morning of Monday, August 27th, the force of the explosion triggered something just as deadly, a massive tsunami. As the volcano collapsed into the sea, it displaced millions of tons of water, sending waves racing in all directions. The tsunami struck the nearby coastlines of both Java and Sumatra with almost no warning. Entire villages were swallowed up in minutes. In some places, waves reached as high as 120 feet. Fishing boats were thrown far inland. Houses, markets, and mosques were reduced to splinters and carried away by the water. People who had survived the ash and falling debris now found themselves facing an even greater danger, the ocean itself. Some of the most devastating damage occurred in the town of Merak, on the coast of Java. Eyewitnesses described how the sea suddenly pulled back, leaving fish flopping in the sand. Then a towering wall of water appeared on the horizon. Within seconds, it crashed into the town, wiping it off the map. No buildings were left standing. Farther away on the island of Sumatra, the waves still reached with terrifying force. One survivor from a coastal village described climbing a tree to escape the water, only to be thrown back down as the tree was torn from the ground. Entire families disappeared. Those who lived through it often did so by clinging to pieces of wood or floating in the floodwaters for hours. Even ships at sea were affected. Some vessels reported being lifted and thrown by the sudden waves, while others vanished without a trace. reports as far away as Sri Lanka and India recorded strange water movements caused by the tsunami. In the Indian Ocean, the shockwaves continued to ripple outward, eventually being recorded on tide gauges as far as South Africa and even the English Channel. The death toll was staggering. Over 36,000 people lost their lives, most of them from the tsunami. In many coastal areas, there were simply no survivors to tell what happened. The landscape was changed completely, towns erased, harbors reshaped, and the coastline carved anew by the sea. Krakatoa's eruption was over, but the suffering had only just begun. The people who lived through it faced a world that looked nothing like the one they had known the day before. After the eruption and the tsunami, Krakatoa's effects continued to spread far beyond Indonesia. In the weeks and months that followed, people around the world began noticing strange and beautiful changes in the sky. Sunsets turned deep red and orange. Some places reported purple twilights and golden clouds. In cities like London, New York, and Rio de Janeiro, the sky glowed in unusual colors long after the sun had gone down. These changes were caused by the massive amount of volcanic ash and gas that Krakatoa sent into the upper atmosphere. That ash spread across the globe, carried by high winds, sunlight hitting the tiny particles scattered in a different way, causing the strange colors. People did not know at the time that what they were seeing was connected to a volcanic eruption on the other side of the world. In some countries, people thought the red skies were signs of war or a message from God. Artists and writers tried to capture the strange light in paintings and poems. One of the most famous paintings from that time, The Scream by Edvard Munch, is believed to have been inspired by the red sky that followed Krakatoa's eruption. But the ash did more than change the sky. It also affected the weather. The sunlight that reached the Earth's surface was slightly reduced, causing global temperatures to drop. The year after the eruption, many places reported colder weather and strange patterns in rain and snowfall. This cooling effect was felt for more than a year. Scientists at the time were still learning about volcanoes, but Krakatoa helped change that. It was one of the first natural disasters to be studied using worldwide communication. Reports from telegraph offices and weather stations were collected and compared. The event helped scientists understand how volcanic eruptions could affect the whole planet. Krakatoa's eruption also taught a painful lesson about warning systems and preparedness. Many people living near the volcano had no idea of the danger they were in. Afterward, efforts slowly began to improve ways to monitor volcanoes and oceans. Today, that tragic eruption is one of the reasons early warning systems exist for tsunamis and volcanic activity. In the end, the eruption of Krakatoa in the year 1883 was more than just a disaster for Indonesia. It was a global event that shook the earth, changed the sky, and left a deep mark in both science and memory. The volcano itself was mostly destroyed, but its story still lives on as one of the most powerful and far-reaching natural events in human history. Mount Pelée sat quietly on the island of Martinique in the Caribbean for a long time. Most people living nearby had no memory of it ever erupting. It had shown some signs of activity in the past, small eruptions in the years 1792 and 1851, but nothing that caused real fear. Because of this, people thought of the volcano as more of a natural landmark than a threat. Life in the town of Saint-Pierre, just over 6 miles south of the mountain's summit, went on as usual. It was a busy and beautiful place known as the Paris of the Caribbean, with shops, schools, a theater, and busy streets. In early April of the year 1902, a few locals noticed something odd. People hiking near the mountain reported strange smells like rotten eggs coming from the summit. These smells were from sulfur gases leaking out of small cracks called fumaroles. But sulfur fumes weren't all that new for the area, and no one thought much of it. That changed on April 23rd when the volcano let out its first real sign of trouble. A light rain of ash and small rocks fell on the southern and western sides of the mountain. Tremors shook the ground. People in the nearby villages felt it, but most still believed it would pass. By April 25th, a dark cloud of ash and rock shot up from the volcano's top. It looked frightening, but it didn't do much damage. Even then, local leaders didn't raise the alarm. On April 26th, another blast dusted nearby towns in gray ash. The volcano was clearly waking up, but officials continued to believe it posed no serious risk. 2 days later, on April 27th, a group of curious hikers made their way up to the summit. What they saw was shocking. The once dry Etong Sek crater was now a lake, boiling and steaming. A cone of volcanic debris, about 50 feet high, had formed beside it. Hot water poured into the lake, and the deep rumbling from below the earth sounded like a huge pot boiling over. The smell of sulfur had become so strong that it reached the streets of Saint-Pierre, causing people and animals to gag or flee indoors. By the end of April, rivers running down the mountain swelled. Some carried trees and boulders with them. Ash started falling steadily on villages like Précheur and Saint-Philomène. Even though these were clear warning signs, people living in and around Saint-Pierre still didn't leave. Many believed the volcano would settle down again, just like it had in the past. Others thought the city was too far from danger. After all, it was over 6 miles from the summit. On the night of May 2nd, around 11:30, the volcano exploded again. It sent out a huge black cloud of ash and pumice, and the explosions grew louder. The ground trembled. Ash rained down on the northern half of the island, and the air became hard to breathe. These blasts were now happening every 5 or 6 hours. Even with all of this happening, life in Saint-Pierre mostly went on as usual. People were nervous, but there was no order to leave, no official word telling them what to do. That weekend, a local newspaper decided to cancel a picnic planned for May 4th, just to be safe. It was one of the few signs that people were starting to worry. Farm animals, however, had already begun dying from starvation and thirst. Their food and water had been covered in ash, making it impossible for them to eat or drink. The island was clearly changing, but the people didn't fully realize what was coming. In the days ahead, things would go from bad to deadly. And yet, even as the ground rumbled beneath their feet and the sky darkened with ash, most people stayed put, unaware that their time was running out. By the end of April in the year 1902, the signs coming from Mount Pelée were growing harder to ignore. Even though many locals still believed there wasn't much to worry about, the mountain was changing quickly. Ash was falling almost daily, and the smell of sulfur filled the air around Saint-Pierre. Nearby rivers started to swell with muddy water, carrying fallen trees and rocks down from the slopes. On April 27th, some people climbed up to check out the Etang Sec crater. They found a lake of boiling water nearly 200 meters across, with steam hissing from deep underground and a strong sulfur smell in the air. That same smell drifted as far as the city of Saint-Pierre, which was over 6 kilometers away. Farm animals were beginning to suffer too. With ash covering the ground and falling into streams, there was no clean water or grass for them to eat. The air burned the lungs, and horses and cattle were getting sick or dying. Still, the local government didn't take serious action. The mayor and other officials were more focused on an upcoming election. Even though the volcano was getting louder and more aggressive each day, they insisted that everything was under control. On May 2nd, at around 11:30 at night, Mount Pelée let out a huge explosion. A thick black cloud of ash and smoke shot up into the sky. Earthquakes shook the ground, and the entire northern part of the island was soon covered in a layer of gray dust. The noise could be heard for miles, and even the ground itself seemed to be groaning under the pressure. But despite the chaos, people still stayed in the city. Some were scared but didn't know where else to go. Others simply trusted that the worst had passed. There were more explosions through the night and into the next day. Every 5 to 6 hours, the volcano would erupt again, the sky darkened, and the air was thick with ash. Even breathing became harder. Still, there was no official order to evacuate. Instead, there were efforts to calm the population. Newspapers printed updates but didn't sound the alarm. In fact, one local paper had planned a picnic on the mountain for May 4th, but ended up postponing it, not because of fear of the volcano, but because of poor visibility from the ash. On May 5th, things took a deadly turn. A powerful mud flow came rushing down the southwest side of the mountain. It smashed into a sugar mill, burying around 150 people and sweeping debris all the way to the sea. The mud flow hit the ocean with such force that it triggered 3 separate tsunamis. These waves damaged coastal buildings, sank boats, and caused panic among the people living near the water. That night, the volcano exploded again, but this time the clouds weren't just dark smoke. Parts of the eruption were glowing. Lava had finally reached the surface, marking a major shift in the eruption's behavior. By now, Mount Pelée was fully awake, and its power was growing. The eruptions were no longer just about steam and gas. Real magma was involved now, which meant the danger was about to reach a whole new level. And still, with everything that had happened, Saint-Pierre remained full of people. Residents, shopkeepers, families, and even refugees from nearby villages who thought the city would be a safe place to ride out the storm. They couldn't have known that they were waiting at the foot of one of the most deadly volcanic eruptions in modern history. By May 6th, the atmosphere in Saint-Pierre had shifted from nervousness to unease. The skies were darker than usual, filled with thick ash clouds that blocked out the sun. Street lamps stayed lit during the day, and layers of ash coated the rooftops, trees, and streets like gray snow. Breathing was difficult, and many people covered their faces with damp cloths. Horses, birds, and pets were found dead from the poor air quality, and the smell of sulfur never went away. Still, ships continued to arrive in the harbor, and life carried on as best as it could. Inside government buildings, officials tried to maintain order. The governor of Martinique, Louis Moutet, had recently visited the city with his wife. He wanted to reassure citizens that they were not in danger. He even moved into the city for a few days to calm fears. At the same time, reports were coming in from across the island about the mountain's activity, small earthquakes, boiling mud, glowing gas, and loud explosions, but the response remained the same: stay calm. Meanwhile, Mount Pelée was going through serious internal changes. A lava dome had begun forming inside the crater. This meant magma was rising to the surface, but being trapped beneath hardened rock. The pressure beneath this cap was increasing rapidly, and gas was building up faster than it could escape. On May 7th, another powerful explosion blew ash and rocks thousands of meters into the air. Some stones fell into the city, crashing through roofs and damaging homes. People were now seriously frightened, but most still remained. Many didn't have the means to leave, and others believed the worst had already happened. In the hills around the volcano, entire forests were dying from the toxic gases. Banana trees and sugar cane fields turned black. Streams ran hot, and fish floated to the surface, dead. The ground cracked in strange patterns, and wild animals fled or dropped where they stood. But inside Saint-Pierre, many still held on to hope. Markets were open, churches held services, and people tried to continue their lives even as the ground shook beneath them. On that same day, scientists visiting the area tried to gather data about the volcano's behavior. They noticed that the gas emissions were becoming more violent and that the shape of the crater had changed. But their warnings went mostly unheard. The newspapers printed short updates but downplayed the danger. There was a strong sense of denial throughout the island's leadership. In their view, Saint-Pierre was too important to lose. It was the economic and cultural heart of the island, and abandoning it would have been unthinkable. What no one realized was that Mount Pelée had become something far more dangerous than anyone had seen before. It wasn't just releasing steam and ash, it was preparing for a type of eruption almost no one on the island understood. And with each hour that passed, the force inside the mountain kept growing, pushing toward the moment when everything would change forever. On the morning of May the 8th, 1902, Saint-Pierre woke to a strange stillness. The usual tremors had stopped. The sky was heavy with ash, but there was no wind, no birds, and no sound from the mountain. Many residents took this quiet as a sign that the worst had passed. Others were too exhausted to think clearly, having spent the last several nights in fear. Despite the chaos of the past days, thousands still remained in the city. Families, merchants, teachers, and workers who had nowhere else to go. At approximately 8 o'clock in the morning, Mount Pelée unleashed one of the most violent eruptions in recorded history. Without warning, a massive explosion tore through the mountain's side. What followed was not lava, but a deadly blast known as a pyroclastic surge. A fast-moving cloud of superheated gas, ash, and rock that raced down the slope at speeds faster than any human could outrun. This surge reached Saint-Pierre in less than 1 minute. The wave of heat was so intense that it ignited everything in its path: wood, clothing, and even people. Buildings were flattened or caught fire instantly. Ships anchored in the harbor burst into flames. Stone structures crumbled, glass shattered. The surge didn't just burn, it crushed and suffocated. Those who tried to flee had no chance. The temperature of the cloud was high enough to kill instantly, and the pressure destroyed lungs before people could take their final breath. Within minutes, the entire city was in ruins. Fires broke out across neighborhoods, turning Saint-Pierre into a smoking wasteland. The eruption didn't stop there. It continued to release ash and gas into the atmosphere, covering the surrounding landscape in darkness. For those observing from other parts of Martinique, the view was horrifying. A giant black column rising from the volcano, shaped like a mushroom cloud, glowing with lightning and flame. In the days that followed, rescue teams arrived to search the wreckage. What they found was devastating. Of the nearly 30,000 people who had been in Saint-Pierre that morning, almost none had survived. The city, once called the Paris of the Caribbean, had been completely erased in less than 5 minutes. The only known survivor from the city center was a man named Ludger Silbaris, a prisoner locked inside a small windowless jail cell that protected him from the heat and ash. His survival was considered a miracle. Mount Pelée's eruption shocked the world. It was not just a natural disaster, it was a warning about how little was understood about volcanoes at the time. The pyroclastic surge, a type of eruption rarely documented before, introduced a new level of destruction that scientists would study for decades to come. But for Martinique, the loss was immediate and unforgettable. One of its most important cities had vanished, and the scars left behind would never fully heal. After the destruction of Saint-Pierre, the island of Martinique was left in mourning. Entire families were gone, and the cultural heart of the island had been wiped out. Survivors from nearby villages struggled to process what had happened. Many had lost loved ones, homes, and livelihoods in an instant. The scale of the disaster was hard to grasp, even for those who had seen the ash and flames with their own eyes. News of the eruption reached the rest of the world quickly. In France and across Europe, headlines described the death of a city. Relief efforts began almost immediately. Ships arrived carrying supplies, doctors, and volunteers. But there was little that could be done. The area around Saint-Pierre was still dangerous. Ash covered the ground like snow. Buildings were unrecognizable, and fires smoldered for days. It would take weeks to recover the dead, and in many cases, nothing remained to bury. One of the most notable outcomes of the disaster was the change it brought to scientific understanding. Geologists from different countries came to study the eruption and its aftermath. Mount Pelée became a key case for the study of pyroclastic flows, which had previously been misunderstood. Researchers also noted the strange weather that followed the eruption, including red sunsets and ash clouds that drifted across the Atlantic. The volcano's behavior helped shape modern methods of monitoring and predicting eruptions. Despite this progress, Mount Pelée remained active. Smaller eruptions occurred in the years that followed, including one in the year 1905. These events slowed the rebuilding process. Although a new settlement eventually formed near the ruins, Saint-Pierre never regained its former importance. The capital of Martinique was moved to Fort-de-France, where most government and trade activities remain today. The story of Saint-Pierre and Mount Pelée lives on through memorials, museums, and local storytelling. The preserved remains of the city still attract visitors who want to understand what happened on that terrible morning. The old prison cell where Ludger Silbaris survived can still be seen. His survival was used in traveling exhibitions, and he later joined a circus in the United States, where he shared his story. The eruption of May 8, 1902, stands as one of the deadliest volcanic events in history. It serves as a reminder of nature's unpredictable power and the importance of preparation. While Saint-Pierre could not have been saved with the knowledge of the time, the lessons learned from its loss have helped protect other communities around the world. Today, Mount Pelée is closely monitored, and the tragedy that once struck the island remains a powerful part of Martinique's identity. Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through valleys and waterways. One of the most notable impacts was at the Drift River Terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reached those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the cost of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world.